Wow. I hit the screen. All right, let's go. All right. All right. So here we go. That's a great session. Done. That's right. All right. All right. So my name is Brad Meador. Tank is my given rider name. 9-year designer at Altec Industries, coming up on 10 here soon. 15-year SolidWorks user. And I got the CSW in 2018. In my spare time, husband and dad, motorcycle minister, long distance rider, a technology nerd. While I'm at it, because I have no time left over, might as well throw in an electrical engineering degree as well, because, you know, I'll sleep when I die, I guess. I don't know. We'll figure it out. So we're going to go over I'm lazy, tips to optimize SolidWorks to work for you. So how many gearheads do we have in here? Car guys, okay? What about iPhone or Android aficionados that love those kind of devices? Okay? Do you keep them exactly as they come from the factory? No? Okay. Well, why keep SolidWorks that way? So we're gonna go over some things. Set up SolidWorks for you. Do some hotkeys, some mouse gestures, and some peripherals you can add on to make yourself a little bit more efficient. And then at the end, we're going to do a stump and chump. So what we're going to try to do is give you any question. It could be about the program or the presentation now, or anything. I like to open it up for questions at the end, and then at the end we'll get a break, and then we'll go back into Adam's presentation. So. All right, so let's go into setting up SolidWorks for you. And let's share my screen here. Make sure everybody can see everything. All right, my virtual people, can you see the screen? Okay, perfect. There we go. Cool. All right. Let's be there. All right. So we're going to start with the command manager. You know what the command manager is, right? The big thing that's always at the top of your screen. We're going to kind of touch base on that. A lot of people don't know. You can customize and dig around and just have fun with it. So again, it's customizable. You can hide and show all the tabs that's needed. Get rid of the things you don't use, because why? You know, if I don't use it, then why do I need it? And then with that, add the stuff you use, or even create your own. So kind of go up in here. This caveat, this was done on 2020 SolidWorks, so it might look a little different for you. Real quick poll, what year are you guys on? 2022? Okay. Okay. So the visual might be a little different, so we'll go from there. All the same stuff applies. There might be some more editable content later in the software version. So also I use dark mode, so it'll look a little different. So tabs, you can go and select the ones you need, or even create the ones you want inside. So we'll kind of go into that, do a live one, and mess up Adam's settings on his machine while he's getting ready to do a presentation on it. It's going to be fun. And then you can go to Customize tab on the bottom, Customize button, and then just start, doing what you want. So you can come in here and actually click, create your own. So I've created one up there called Tank, and then you can start dragging things in. I do a lot of sheet metal and a lot of standard, extrusions and things. So I put everything I could do from start to finish at left to right. So when it gets all done, it's all in order. So I just click buttons down the line. So it seems to work well that way. Okay. Oh, second microphone. All right. Now I look like the President of the United States with like 8 microphones in front of me. All right. So you said change the audio to what? Just. Yeah, my apologies. We're getting a little bit of audio weird strangeness in here. Seeing it, Adam. you jump over here for a second until we get this thing going? Give me 1 second, guys. We'll get to it over here. Yeah, we'll break this stuff. This. All right, so all right, can you guys on the webcam hear me okay with this new microphone?
Yeah, that's a lot better.
Okay, good, awesome. All right, so we'll go back kind of so everybody can hear a little bit better. So start from left to right, at least on mine. We can kind of go through a part from start to finish and get everything ready to go. And if you notice, there's sketching commands, there's sheet metal commands, there's extrudes, there's patterns, there's even view stuff all in there. So you can kind of grab and drag and a little plethora of things you can kind of customize to what you need. So we're going to switch over to SolidWorks here. All right, looks like it's not on the screen, so we'll switch screens. Let's see, Adam, can we get this to duplicate? Say what? I've got it up, it's just not showing up on the screen.
Close your presentation.
Ah.
Or don't close it, but stop displaying it.
Okay, we'll go back. All right, so again, all this stuff is relatively new here, so let's
Display settings. There you go.
just hit, we'll just do inside, so it's fine. All right. There we go. All right. I know, it's not working now. Hold on. I break everything. Sorry. Sorry, guys online. There we go. All right. So we're going to go up in here. We're going to royally screw with Adam's computer. And by adding things, we're just going to start messing with tabs here. Yes. It's revenge for him changing up all the commands. As you can see up here, when you go into customize, we have all these things you can pick from. Now, you've got some that are hidden and some that are shown, grayed out. What are some that you guys use more than others? Weldments. Okay, we got that one. What else? You don't do any structures or mold tools or anything like that? No? Okay. I do a lot of direct editing and modifications of like externally sourced parts. So if I'm going to use that, I'm just going to show tab, right click on it and show tab. We show it back up. And then everything that's highlighted will allow you to be seen once it's all customized. So you can close back out and it'll show you the ones that you've got on there. So we're going to go back again, and I can come over here. There's a new tab feature. It is blank. So we can come in here and I can just go in and pick any command I want. I can start grabbing and dragging stuff in here in any sort of order, and it kind of gives you a little bit of customization. So if you see yourself using only a few weldment commands, then you can just go ahead and create the ones you need and get rid of all the excess clutter on your machine. It kind of gives you a streamlined approach, less hunting of your commands, less mouse miles on your hand. And you're making yourself a little bit more efficient, because every second counts when you've got a customer yelling at you for parts, right? So I've got this new tab here. We can customize it, or we can get rid of it if we want later, and I can rename it if I want. So go back over here, rename it, and we're just going to call it tank, because why not? And there you go. I've got my tab. It's ready to go. I can use it as is. Or, I don't need it anymore. I'm going to delete it out of there. So we'll go back. All right. All right. Same thing with toolbars and stuff. I know you guys probably have some things customized. Does your IT department lock everything down?
We don't lock it down, but we did like a common registry settings that we push out all computers.
Okay. Okay, so a lot of companies do the same thing. There's going to be some background things that are probably going to be locked for you guys to change, but this one should be one that you can do. Toolbars, we're just going to go back into it, back into SolidWorks, and we're going to see that you can grab and drag things in and out. So we'll just go back into the software. And kind of go what we need to do. So same thing, go back and right click in your command manager, go back to your toolbars and basically cut the ones you want on. And if you want to customize specific ones, you kind of go up here to your shortcuts and all your toolbars, and you can start adding and dragging things in and out. So if you go, we can grab and just start adding things in, just like you did with the command manager. Any specific toolbar, any command. It allows you to kind of tweak and tailor what you do specifically for you as a user. Because I always say you put 100 people in a room, ask them to design something specific, there'll be 100 different ways that the part came out. As long as that part actually fits the final shape. It has different features, it has different layouts, but it'll all come out as the actual part itself. So it's a good way to improve your workflow, get you a little bit more speed, and time always equals money in the workforce. So any questions so far? Feel free to interrupt anytime when I'm doing things. So has anybody ever played around with these things? Hiding, showing? Okay, good. Oh, I got a camera over here too. All right. Along with those, we've got some shortcut toolbars. Anybody ever use the S key, S command, shortcut bar? Super helpful if you have specific hotkeys you always want to use or macros and things. You can add those to it. So it's just right at your fingertips. You don't have to worry about actually having to go dig and find it. Little pro tip, the search button up here, you can toggle down to search commands only. So you can drop your filter and tell it you want to search commands and add a command in or find a command inside your, so we'll just say, we're just going to find fillet. But did you know you can grab and drag it in and drop it into the toolbar directly from the search feature? A lot of people, it's kind of a little hidden Easter egg. So if you can't find it, it'll find it and you can pull it up. So, all right, now where did my mouse go? There it is. Too many screens. All right. Another pro tip. You need to find it, you poke the eyeball and it'll point you to it. It's all-seeing eye, it'll point to it directly and highlight it for you. So if you're trying to find something specific in your commands that you think you need, a little bit lesser known thing, kind of jump into that as well. All right, hotkeys. How many people have set their own hotkeys up? No? I got one in the back, but he's a TriMac guy, so it doesn't count. All right, so we'll do this because it's going to be, there we go. All right, so standard hotkeys, built-in SolidWorks hotkeys and display hotkeys. So everybody knows the standard hotkeys, correct? Control, whatever. My favorite one's Control Z. I don't know if you've ever got to a point where you break something and you just have to Control Z until you get to until you get back to it. What'd you say? Undo. Yeah, repeat, undo. Yeah, that happens to everybody at least one time or another. You add a constraint, you add a mate, red, ketchup and mustard all over the feature tree. So this is something that I keep on. Specific hotkeys. Control B, rebuild features since your last edit. So if your 1,000 feature part, you make one change, it's Control B and it'll update only that one part. Control Q rebuilds the entire model from top to bottom. It actually calculates from top to bottom in your feature tree. So it allows you to kind of tailor how fast you want it to calculate by putting things like display oriented things like fillets and cosmetic threads at the bottom, so you can kind of hide those later if you need to. They help you kind of work a little faster. Control tab cycles through the open file. If you've ever seen that, like alt tab on Windows, you can do that through SolidWorks as well. Enters, repeat. You got the shortcut bar. Fun one is Shift C. So you're digging through 1,000, 2,000 part assembly. You can actually collapse the entire feature tree and have it go all the way up, which is Shift C. A fun prank, what Adam said, is to go up to the feature tree and just type the asterisk key, and it'll explode your entire feature tree down to every single sketch and feature, which is a cruel prank to play on somebody if you've got 10,000 parts in a large assembly. It'll lock their machine down for quite a while. So, but you can always make them feel better by just hitting Shift C after it's all done, and it'll collapse it all back for them. So we like to preface that. Display hotkeys, zoom in, zoom out. I don't know if any of you guys ever use the 3D space mouse that kind of does that for you. You can make it go a little faster, but if not, you can always do the Z button and the Shift Z on your keyboard, and it'll do the same thing. Shift and drag, zoom out on screen center. F is fit in the middle, and then space bar is your view selector. So we'll just kind of jump back into it here. And simple, space bar, S key. Oh no, Adams is not working. Oh, he customized it. Get you next time.
You told me to customize my hotkey.
Yes, I did. Okay. All right. So things like your middle mouse button, you get your shift and middle mouse button. It'll do zoom in and out. That's if you're specifically looking for something. Not many people use that much command anymore, at least not that I've seen. Most people have the 3D mouse, or they just use their mouse wheel and drag and kind of do what they want. So, oops, I zoomed out too far, or I zoomed in too far, F key. Simple little things. So just kind of glance over that a little bit. Oh, I'll show you that. So we'll explode the whole feature tree. Oh, no, yours doesn't do it. Oh, proved me wrong. Okay, well, let's blow it up down here for a second and get to it. Shift C comes back up and collapses everything again. So if you're in, big assemblies and things, you can always make your feature tree a little smaller when you save it or when you're looking through things. So gives you a little bit of more control over your software. Mouse gestures. Everybody use those? Seen them? Play with them? No? I see some yeses and some nos. Little nifty command. Grab your right mouse button, and you can have a wheel of all your commands right there. So if you are so inclined, you can hire your command manager up top, shrink your feature tree down, and have this giant viewport to work on, and you can work directly off of mouse gestures. Now, we'll just kind of skip that section of the PowerPoint. I'll just go directly into customizing and how to set them up. But why do you think you would want to use a mouse gesture right in the middle of your viewport, right? It would be to keep you from having to go toolbar hunting for all your commands. We just set up the toolbars, but if you don't want to do that, you can share your mouse gestures up. And you can even do something like your S key command, like this one, brings up your S key commands. You don't have to touch a keyboard. So if you have a 3D mouse, or you've got a macro pad, or you've got a specific keyboard, you don't even have to touch it. You can just bring all your commands up. So customization is the same as all the other stuff. Go into your customize tab, click your mouse gestures. Now this is where I get to have the fun and really mess with them. So we can come in here and just start dragging out commands. And we can kind of go through here and find the commands we want to pick and just grab and drag them in. So you can select 2, 4, 8, and 12 mouse gestures. So if you want to start and you want to just play around with some, you know, you can, the more advanced you get, a little bit more control you have, you can add more things to them. So, I hope not. I hope not. Anybody actually used full 12 besides Adam because he's an anomaly? No. How many does people use? 4, 8, 8. I see an 8. How many? 4, 2. Okay. I will encourage you to try, if you haven't used it, try to start with 2 and then work your way up on the commands that you find useful. For me, it's all the drawing view stuff. The section views, the detail views, that kind of stuff inside the drawing. But you can see we've got different ones: part, sketch, drawing, and assembly. So you can customize each one to do the commands that you want. Adam here's got some linear patterns and some, edit part and all that stuff in here. For assemblies, drawings, he's got notes and whatnot. Balloons, he's got 2 stacked balloons in here. I'm going to ask why. Okay, just in case. Okay.
In case I go off on the wrong way.
Okay. All right. And same thing, all this stuff is infinitely customizable. So you can kind of pick, set the thing up. Again, your company already presets something to you, but why do you want to, just stay with that when you can actually customize it to make it work for you directly? So highly recommended to go in and do that. All right. So let's go down to, we've already set it up. All right. So that's nice and all, but what happens if you get a new SOLIDWORKS version, or you get a new computer because yours crashed, or God forbid you actually have to get a new job? You've already got it set up the way you want. You can save your mouse setting, all the settings, right? Has anybody ever done that, backed up their user settings? No? Okay.
Like I said, we do a common registry setting that we push out into computers.
Okay.
I think that's why everybody doesn't have their own customization, because they don't want to lose it.
Yeah, well, I mean, and that's fine. So if you do a common registry setting update, you can always go back and reapply that settings later.
That's a very good point. I know at Altec we did the same thing.
Yeah.
We have a model standards team, and SOLIDWORKS champions that get their heads together and come up with the best use case for the company. And it's mostly out of the box. It's really good for a lot of entry level users. But just to preference that with, we had a discussion with some engineers earlier. You give 100 engineers something to draw, and you're going to come back with 100 different ways of it being done. And everybody can find a way to be more efficient. And of course, having those tools right out of the box are going to be definitely something you want to do. But if somebody needs a certain tool, definitely add that tool. I mentioned this earlier. My older son called me from work the other day. He's like, "Dad, I've got the linear pattern. I have to keep going, hitting the drop down menu, hitting linear pattern. How can I make this easier? I don't want to do this every time. It's ridiculous." I said, "You use mouse gesture. You use ESCI.
Why?
Why not? Let's
Yeah.
show you how to do this. Let's put that on your mouse wheel because you're going to use that." And
Yep.
I enticed him and treat them saying, as you go about your daily function, find out what tools you use the most.
Yep.
And when you find out those tools, or you make a list of those tools, make those part of your mouse wheel, shortcut key. And as a super user, I think Omo pointed that out online, is I have that shortcut menu on each environment of my mouse wheel, so that I can actually, and it's in the same location as well, because whether I'm in drawing, sketches, assemblies, I can easily use my mouse wheel, go right over shortcut, or a different shortcut, and I have even more options. And reducing my mouse miles allows me to keep right in where I'm zoomed in and focused at versus traveling all over the screen.
Yeah. So if you take away anything tonight, go in the copy settings widgets and at least walk through how to set it up. You could save it to a thumb drive. You could save it to your desktop. There's just a little small text file that gets saved in your registry, even if it's something that's changing the color of your background. That's all saved in there. So if you, like, I use dark mode, so all that stuff is already saved in to my user settings. So when we push an update or we push a new version, I can just go back through, reapply all my settings that are toolbars and display and everything, just not the system settings that are in there. You can actually tell it to go in and only do certain ones when you upload. So try to play around with that if you can, if you have some time. I would show it to you, but I have to close SolidWorks to do that, and I don't want to shut that down while we're live. So yeah, it's easy. It walks you through it one step at a time. So it'll be easy, and even tells you can even point at where you want it to go and give you a copy. So we'll go from there. All right.
Talk on this too long, but I do have one more question.
Yes.
And it's a problem we've had. When you do restore settings, we manage our toolbox from within our vault, medium vault. Anytime it loses where the toolbox is.
Interesting.
And it's saved in our registry settings where it is.
That is a.
It tries to go back to SolidWorks default instead of our vault location.
Okay, that.
When you restore the, you can also recommend certain things you don't write.
That might be what you might want to check that to make sure it doesn't overwrite. I imagine it goes to whatever default.
Probably your system option that you file location.
Yeah.
And so you just kind of check that. You know, restore mouse gestures, keyboard shortcuts, system options, or
Yeah.
whatever. There's a whole plethora of stuff.
But-
You can say backup or restore.
Yep.
I made a suggestion to a guy earlier. He said, "Can I back up everything and restore everything?" Well, yeah, you can. Maybe just back up everything when you restore. You only restore the mouse gestures and keyboard. You have everything backed up that you need.
Yep.
You don't have to restore it.
Then there is some more hidden registry files you could change for cat admin to update that maybe you have to dig into that. But if it doesn't work, it'd be a bug fix you can submit.
And there is a way on the admin side that if you run through a DOS prompt first for it to open, it can actually wipe the user settings to go back to 4% every time.
I don't like that one.
Yeah, you don't have to do it.
We're
We're
not
not
trying
trying
to
to
discourage people from having their own.
Yeah, that
When there's a problem, restore.
yes. Yeah, and we have the DOS prompt on ours that changes certain things every time. Yeah, things like your template locations and stuff, because I'm sure you have them located on a server somewhere that you can reach, correct? Yeah, so that'll be where they would be. All right, so we're going to go into peripherals. How many people actually have used a 3D mouse? 2, 3, okay. How many people want to use a 3D mouse or even curious about it? 1, okay. All right. So we'll kind of do some examples here. Gaming mice, or even, Adam, will you hold that one up? 3D Connection, the guys that make the 3D mice actually make a CAD specific mouse. It's got extra buttons on it. And you can actually cut, all right, Vanna White, that you can add extra buttons, zoom, you can add macros to it, anything that actually make you speed up. So I've got some extra commands in there saved, and you can that one's even got a button to throw an extra set of mouse gestures out. So if you want to add extra mouse gestures, you can do that as well. So a little bit more customization. Gaming keyboards, any gamers, computer gamers? Advanced gaming keyboards have macro keys added all over the place. You can add all these extra buttons, extra commands, so you're not having to go through and toolbar hunt for things. You can just push G1 or G2 and it's your create drawing file or add a projected view. The biggest advocate I have with these is the 3D Connection product. I'm sure you've seen these things around at people's desks. The basic one's a little puck. The bigger one has more buttons on it. And then the enterprise one actually will read email if you're so inclined. I've never once seen anybody actually use one because they're really pricey. They're about $500 out the door. But if you wanted it, it's out there. They even make wireless versions of every one of them except for the enterprise. So if you have a laptop and you want to use wireless, you can use the wireless of all these, and they're rechargeable and everything. So highly recommended to try. At least put your hands on them and play around. 3D Connection will send a guy out and let you try them out, or even give you some samples to try your engineering managers if they want to dedicate some users to them. I mean, the little puck is $129 for the wireless one on Amazon. So it's a very tiny expense to make your life faster. So, and another one is game boards. If you're a super computer gamer, These are like macro pad kind of things where you add more buttons to your keyboard essentially with a USB port. You rest your hand on it, and it's even got an extra little mouse wheel like you see down here, little joysticks and extra buttons. All this is assignable, so you can put your commands to it. Heck, you can have no toolbars, nothing, and just run everything off these peripherals if you wanted, and not have to touch your keyboard until you have to read email, which in the case you can add one of those 3D experience things to read your email for you if you wanted to. But again, I've never seen one actually used before. All right, last one, macro keypads. These are kind of old school technology for computer programming, but it's available out there if you really wanted to play around with it. So reduce the motion waste. You saw how much my mouse, I don't know if you can see my hand, how much my mouse is moving. There's a program called Mouseotron you can download if your IT will allow you. It will actually show you how many miles your mouse moves in a day. And it adds up fast. How many clicks, how many inches it moves, miles. It'll actually come all the way up to miles. And it helps, keep you a little bit more focused on your work rather than sitting there going, okay, I got to drag my mouse all the way across here to click this button or all the way back. So keep your macros and commands kind of like at your fingertips, really. Keep your hands in an ergonomic position. I know we've all got these really expensive computer desks and computer chairs to make things comfortable, even standing desks. So why not keep your hands in a comfortable position so you don't develop carpal tunnel? Dedicated buttons for your regular things that you use, and then motion waste, and wasted time equals wasted money. So 3D Connection, a little caveat, 3D Connection did a motion waste study when they did these 3D mice. So 3 minutes over 3 minutes per hour is a 5% motion waste. Zooming and rotating and panning on a part. Times it by 40-hour work week, it's 120 minutes saved per week. 44 weeks worked a year. That's 5,280 minutes. That's 88 hours of saved time. At $55 an hour, that's $48.40 in waste savings per year. So it offsets the cost of actually buying a $129 accessory. Plus, it helps keep your users happy. So, so keep in mind, again, this was done by 3D Connection, so a little bit of this can be taken with a grain of salt, but users less fatigue on their hands. They're not having to move and zoom and rotate using the mouse wheel on the mouse, or even a third center button if they want. Less muscle fatigue on your wrist and on your forearm, carpal tunnel area. And again, so it kind of gives you an idea with and without the 3D mouse command, navigation command, but you can actually do both at the same time. Little pro tip, when you're rotating things with a mouse using the wheel, every click of that wheel, it's causing the graphics to regenerate in the viewport. So you rotate it, it regenerates. You rotate it, it regenerates. Or if you're using the wheel, zooming in and out, every click is causing it to regenerate. When you're using the space mouse, they've worked with SolidWorks so that the moment you touch it to the moment you let it go, it doesn't regenerate until you let go of it. So it actually speeds up the software calculation just a tad. So it does seem to work pretty well for people. Also, it's so popular it's used on a TV show. Can you see it? This is actually from Sci-Fi Channel. Do you see it? Yeah. Some set designer was like, that looks futuristic, let's put it on there. So something that we like to kind of play around with. And like a Power Glove, like a Nintendo Power Glove. Huh? Yeah, the Nintendo Power Glove. I wonder if somebody can figure that out with an Arduino. Uh-oh, science project. All right, so what'd you say? Yeah, weird science, yep. All right, so we're at Q&A, so you can ask me anything about the presentation or any just in general SolidWorks questions. I like to try to field questions, any struggles you guys are having, any design issues you guys have. I like to kind of throw it out there and try to stump the chump. I like to call it.
For now, suggestion. Have different numbers. Did I say have 8 for sketch?
Not yet. I don't know if that's a thing yet. That would be a nice customization to add in there. That could be something that you could submit an enhancement request through SolidWorks and have them do that. That would be nice to have, because if you only use 3 or 4 assembly things like mate and insert part, there's no need to have 8 solid ones all the way around, or 12, or why limit yourself? That's a good idea. It's a good enhancement request. So who's the CAD admin?
I am in Marty Glass.
Okay. No, there's a way to do an enhancement request, and you can tag your license on it. And so every seat will enhance the enhancement request up higher. So
I think Jason's. I have that never been active one.
okay.
And it's still a very good request, but I gave up.
Okay.
The alternate position, you in a section,
Yeah.
why can't you do that?
That's an interesting one. Alternate projection view in a section. Okay.
Yeah, because some things you can't see without taking a section, and you show in 2 different positions in the section, but.
That's interesting. I've never heard of that tried. That'd be something interesting to see.
Moving parts, you can't see it.
Ah, okay.
Everything's on the exterior.
That's a great design. Everything you just bolt on to the top, right?
Yeah. So Chris Robertson on the Zoom, he likes to 12 steps with the SKI, one of them.
Yeah. So you can put agreed, like your S key directly on there, so you don't have to touch your keyboard. Okay.
Or if you change your SKI to something else.
I know. I see that. Jeez, making it hard on me. Customizes SolidWorks within an inch of his life, and then expects me to try to do a customization. Okay. All right. Any more questions so far?
We need to match everything to fix all our download.
Ooh, that'd be hard. Have you heard of 3D interconnect though? Okay, so 3D interconnect is a thing inside of SolidWorks. I think it started in 2019, where it will open non-native CAD files. So it'll open an Inventor or a CATIA or a Pro-E or Creo, I guess is what it's called now. And it'll open it in there. So you don't have to, get a step or an IGES or a Parasolid and have to fix all the mates or fix all the faces.
I don't know, I'm not sure if it's interconnected or not. It may not be, but we're also working a lot better with those solid models.
Yeah.
SDLs, some of them solid models where you can modify.
Yep. That's the direct editing is what I do a lot of. We'll get a booker, and then suddenly you convert the step file to a model, and there's 1,000 broken faces. And what do? You spend a week.
I think so.
Heel gap, delete face,
I think SolidWorks is realizing a lot. Some sort of reverse engineering.
Yep.
Into their model or whatever.
Yeah, because there's no need for me to have internal parts of a hydraulic valve. I just need the outside. So I'm in there gutting the parts out and making it watertight essentially, and then converting it to a solid at that point. So yeah, that would be nice. But I would check 3D interconnect if you have not tried it. There's a setting inside, so you can, drop in a valve or if you've got specific parts you need or a non-native file. Do you have to convert everything to store it in your PDM? Yeah. Okay. That will be where it gets tricky. Yeah. What PDM do you use? Do you use the SolidWorks one, or do you use something else like Windchill? Okay. Smart. We use Team Center. Yeah. Yep. All right. Any more questions so far? I don't think so. I think we have interconnect on regular ones too. Yeah, What'd you say? It was on overall?
Yeah, he said, Tommy said.
That's what I was thought, because we've had some users get really confused when working with that, and we've had to have them turn them off if they're not used to it.
I thought it was just a program.
Okay. Yeah. Okay. All right. So we'll kind of go to the Q&A.
So the presentation I'm gonna be delivering today, I probably just show one thing here. I just want to give you guys a teaser. For those of us in this room, if you guys know a little bit about IronSWUG and what we're doing here, we're actually traveling around from different locations. Lex had mentioned, you know, tanks coming from Roanoke. I'm coming from the Asheville area. We left yesterday. We had some roadside trouble that we had fixed, and it was a blessing that it actually happened because it allowed us to be in a garage for about 4 or 5 hours wrenching on a bike while the rain was coming down versus being on the road getting rained on or being stuck in a parking lot wrenching on a bike with limited tools. So that worked out really well. It did get us in pretty late last night. Go ahead and switch cameras. Thanks, Tank. It did get us in pretty late last night, which is fine. We are running on about 5 hours of sleep, about that. So, but this is great because we're able to get around and rub shoulders with all the users in the Southeast area. We visited Altec for a lunch and learn today, spent about 2.5, 3 hours there with them. We're here this evening. Each night this week will be at a different location. So tomorrow night we'll be in Pensacola. Wednesday we'll be in Atlanta at Georgia Tech. Then Thursday we'll be in Charlotte, and Friday we'll be back at my home SWUG group in Asheville. So we're really excited to get out and get around and see these different locations. And of course, IronSWUG, we are doing it on the back of a motorcycle. So we're traveling these, I'll go ahead and throw this image up here. Traveling, you know, 2,200 miles, 2 motorcycles, 12 presentations. And we're hoping this will be one epic ride for not just us, but for all the users that are involved in this. I want to bring you guys along for the ride. And on Eventbrite, I know it's listed on the meetup page. So if you guys get on your meetup page, you can go to the Eventbrite link. You can follow us along. Tank has set up a link that you can actually follow us as we ride every 5 minutes. That GPS updates and shows you where we're at and as we move around. So that's pretty cool. Also, we have Instagram links there that you can see what's going on with it. But more than that, on that Eventbrite page, it shows each location where we're at and what presentations we're delivering. So we want to invite you, just like the other people out in virtual land today, as we're sitting here in front of you, that we'll sit in front of the other people. You guys can tune in virtually throughout the rest of the week as well. I actually bring that up because, you know, Tank was talking about some peripheral devices, and just real quick, let's see. Probably enter my presentations here. He talked about being an anomaly. I really chuckled at that because Tank, you know, mentioned me being an anomaly. That's probably not far off. Let's see where my presentation is at. Just, PowerPoints, there we go. That's how I roll. So I entice you and encourage you to attend tomorrow's presentation as Brad and I present again, each one of us on different presentations. Mine is going to be how I roll. Do my peripherals work for you? And so I'm going to talk about a lot of different peripherals and how I use them and different things you can use. So just FYI, little blip for tomorrow. Hopefully you guys can attend that Zoom meeting. We're in Pensacola. All right, moving back into mine for tonight, sheet metal basics is what we're going to be talking about. So I don't know how much you guys use sheet metal. Tank and I use sheet metal probably every day, especially me. I know I use it every day, all day. I dream sheet metal, wondering, you know, if this is going to bend that or that's going to bend this and what holes will wrap around an edge and all these good things. So yeah, sheet metal basics, fold it your way. How to create sheet metal parts, we're going to talk about that. Working with sheet metal features and manipulating sheet metal features, right? So those are kind of the 3 main things we're going to look at. All right, so a little bit about myself. My name is Adam Ebernickel. I'm a senior designer, product engineer for Altec Industries. Been there almost 10 years. I also adjunct in the applied engineering department at Mayland Community College, which is 5 minutes down the road from where I work during the day. Co-lead the Western North Carolina Asheville SWUG group. I'm also the SWUG committee member for the Southeast Regional area. So hence why we're hitting the Southeast region on this kickoff here for our first annual IronSWUG event. But also here recently, Altec, our company that we work for, has really taken an initiative in bringing in-house a lot of SWUG groups. So we've got the one here in Birmingham, we've got the one in Burnsville where I'm at. Tank is working with the gentleman up in Roanoke, helping them out where they've developed one. We've got 3 other locations that are coming on board. So I'm also the committee member for the Altec user groups as well. Like Tank, I'm also a SolidWorks champion. So when SolidWorks needs help or they got different things going on, they kind of call on us and look for us to do some certain things, as well as being certified SolidWorks expert. Some of the key takeaways from this presentation that hopefully you guys walk away with. One, how to create a sheet metal part. You know, what's just the basics of it? How do we even get into that? And then working with the sheet metal features and manipulating those sheet metal features like I was mentioning a minute ago. The first question is, do you even have the sheet metal tab? So Tank brought it up. He showed you how to customize and pull up those different tabs, whether it's weldments or mold tools or whatever else. So make sure you got the sheet metal tab. Pretty easy. You just go to the top, you right click on your ribbon, you go to customize, find that sheet metal tab. If it's not available for you, right click on it and just tell it to show tab. That'll be there. Once you have it, you got a lot of different things there. So now once we have that, we can actually go ahead and start. Something else we should consider though is the templates, right? And creating base flanges. A lot of times you can create different parts, and it sounds like what you guys were speaking of earlier, you kind of have some preset stuff, so you probably have templates and stuff set up, right? Part templates and okay. So if you're working with sheet metal, you probably have the same thing going on there. Yeah, so where do we start? We start with go ahead and create a base flange. Let's see. But one thing we'll point out when we go through these sheet metal features and creating different tabs and flanges is there's multiple ways to do things. And we talked about that, kind of brought it up. It was something Tank mentioned earlier today is you give an engineer, 100 engineers something to do, they're all going to come back 100 different ways. But what else can we consider when we do those things, right? Is it the best move to do? Do we want to just create a base flange, draw out a flat piece, fold up a couple flanges after that, have multiple features in the tree? Do we want to do a contour flange, right? And I'll jump into some of this and explain it in SolidWorks as well. Or do we want to just do a contour flange and maybe have the base flange and 2 flanges coming off of that and creating it in 1 feature versus 2, right? That's kind of up to you and what you plan on doing with that. And we'll talk a little bit more about that as well. So we'll look at sketch placement. Which plane should you consider? Should you center it about the planes? Sketch type and orientation, whether you use an open sketch or a closed sketch, the orientation of or the placement or in your drawing, so that can play into it. You know, whether you're putting it in a certain place or on the origin, or maybe where you're fitting it up with the planes. Do you need to center it about something once you get it into your assembly? So those are a lot of things we're thinking about in the future. And we're talking about that design intent, right? Well, we're getting ahead of ourselves and we're looking into the future. It's like playing chess. And I like to use the chess as a good example for a lot of design tools, right? Because in chess, when you sit down to play a game, you don't think about just moving that pawn 2 spaces up, right? You think about, well, if I move this pawn, he's going to move his pawn, he's going to move his rook, right? And ultimately, the point is to get checkmate, right? And so where do those moves come from? So thinking ahead, how does this affect the guy down the road? How does it affect when I place these flanges here and I maybe add a cutout, and then I go back and I add those dimensions in certain locations, how does that affect those flanges and cutouts? Is it gonna move the way I want it to move? So design intent is a big thing to think about whenever you're deciding the planes and whether you have open and closed sketches and stuff like that, right? Whether you're cutting or you're tabbing, you're doing parts and your mirrors, how you add those into your sequence, whether you draw half of the object and then mirror the whole thing over, what will it lay them out mirror? Because I know sometimes you'll get in there and you'll do some cuts and tabs and some fillets, and sometimes it won't let you mirror it, right? A good point we brought up earlier in today's meeting this afternoon was, where should the fillets be? If you're going to go in and fillet the edges of your sheet metal or any extruded part for that matter, where should it be? Should you do that first up in the higher part of the hierarchy of your feature tree? Probably not. It should probably be in the bottom. It should be one of the last things you do. Because if you have to simplify the part, it's an easy thing you can go ahead and delete without ruining or wrecking the rest of your model, right? Plus, SolidWorks is going to solve it a lot easier that way too. So yeah, using that design intent and which way you're going to use those. Gauge table versus manual parameters, right? And we're going to talk a little bit about that, how that comes into an importance. Do you guys use gauge tables any? Okay. Use it for duct work. Do you guys use gauge tables at all? You look at gauge and you type it in manual parameters? Yeah. That's exactly what I'm looking at there, right? Gauge tables versus manual parameters. Nothing wrong with manual parameters. I mean, you can do that. We did it at Altec for how long, Tank? I mean, before we pushed the gauge tables and had people actually start following suit. Yeah, for a long time, right? I would encourage the use of gauge tables. I'm going to get into gauge tables just a smidgen here. I do have a presentation coming up later this week that is the sheet metal advanced part of it. I'm going to get more into gauge tables there. They're very easy to use and they make for consistent drafting, right? So no matter whether you use something a certain way and you say you want, 12 gauge at 0.105 and, the next guy down here says he wants 12 gauge at 0.0555, whatever, you're getting from your vendor, maybe they're going to the next decimal point, and those decimal points can add up, right? And so if you have a gauge table, everybody's selecting it from the same thing. It's preset, right? You guys, I don't know if you guys use do piping and stuff, right? So do you guys use templates for your scheduled pipe or whatever it is, and you pull that base in and kind of extrude along that, or how do you guys? A library. And this is okay. Made a great point, right? So you had to go and look it up online. Nothing wrong with that. Again, these SWUG groups are great for learning, right? And so how long did it take you to go look it up online? How much more time did you use to look it up online and have that? Well, if you have a gauge table set up in the background, when you go create a sheet metal part, all you do is select gauge table and select the gauge you want to use, and it populates everything for you. And everything after that can be linked to it and follow suit.
That's what I'm saying. It's just the gauge table.
Yeah, you basically, and I'll just give you a little snippet of a gauge table, what we use and how simple it can look. And it basically just uses the data right from a spreadsheet. Yes, yeah, and I'll show you that too, because we have it set up for a plethora of types of metals. So I'll give you a little snippet of some of that too. Yep. And where that benefits you is time savings, efficiency, right? And consistency. Okay, so we'll talk a little bit about that. And again, if you want to catch my sheet metal for advanced stuff, even if it's just the few people that use it, want to tap into that Zoom link later on this week, please do. Because I'm going to talk a little bit more about advanced stuff, and gauge tables is going to be part of that. All right, so yeah, creating and using those gauge tables. So here's what gauge tables do. I've got a little bit of a snippet here I was just talking about. So if you use a gauge table, you simply have to create a spreadsheet and fill out the information, right? So you're gonna have type, process, K factor, units, which is inches. You're going to list out the type or size of the material. Like you see here, the gauge numbers, 1/2 inch, 3/8, quarter, 7 gauge, 10, 12 on, and so on, right? And then in correlation to that, you say, oh, how thick is that material? Well, of course, 1/2 inch is 1/2 inch. Of course, you're going to have different ones, like 12 gauge is 0.105. Some people may want to go to the next decimal. It's how crucial is that for you when you're bringing it in-house or wherever you're having it done, and they're doing a quality check, right? You want to make sure that's taken care of. But then also, like Tank was saying, you can set that bend radius, right? On the press brake, if you're using a press brake, what die are they using? Is it a 1/4 inch die? Is it a 1/2 inch die, an 1/8 inch die, 16th inch die? And set that up according to what it applies to which material, right? And then you don't have to worry about it. When you go and create the sheet metal table, it'll populate that when you select it. Now up in this top right-hand corner, you can kind of see a little black snippet there. That's all the different sheet metal or not all, but a lot of the sheet metal tables that we have set up just between a couple facilities where we have aluminum rod, we have pipe, we have tread plate, we have aluminum. I don't think I'm going to get into this and this one. I'm pretty sure it's in my advanced sheet metal later on this week. But for example, rod and pipe, right? Sometimes when you do rod and pipe, and I don't know how you guys do it, a lot of people just sweep the stuff, right? And I'm getting ahead of myself for later on this week, but a lot of people sweep it. Well, how do you unfold that? Unless you're trying to do some kind of surfacing magic, right? How do you unfold it? Well, why don't you treat it like sheet metal, radius the edges of it, and then you can bend it and unfold it just like sheet metal and use the sheet metal gauge tables to help formulate all that for you, right? All right, so when creating a sketch, you can first open the base flange tab. You can choose an open versus a closed contour. And when I look at that, you can see the right versus the left. You have the open contour, you have the closed contour, right? The open contour is going to be more like a contour flange where, say, I've drawn, I don't know, at least 2 legs, right? At least an angle of some sort. I can draw as many as I want. I can go up to hundreds, right? As many as SolidWorks will let me. In this instance, I basically just drew a cheap channel, right? I just gave you 3 legs. And what happens when we do that, and you'll see it when we get into the example, is it basically gives that thickness at that point around the legs, right, of that sketch, of that open contour, and extrudes out the distance. And we'll talk about how do we extrude that distance. What is the smart way of extruding it? That's, again, all up to you. It's all design intent, right? Then we go to the right side of the screen and we looked at the closed contour. And this is where we basically we've drawn a rectangle. We put a couple of circles in there. We probably located them on midpoints or dimensions or, kind of made everything symmetric about itself. But you see the difference in what it created. One followed the shape of the sketch line because it's open. The other one closed it in like a plate. All right. And again, that's up to you because as I'll show you here in a minute, when we get into the flanges, how do you build those flanges? Because now if I take the closed contour and I put 2 flanges on it, what did I just do? I either created at least 1 or 2 more features that can possibly even slow down my model, right? All right, so let's go ahead and jump into SolidWorks. Let's play around here a little bit. SolidWorks. All right, so this is one I was just kind of playing around with, and we've got some different stuff. I'm just going to kind of point out a few things here. Let's start with the basics, actually. So I'm gonna go ahead, open. I'm gonna hit a new part, and these are just our templates, right? You guys probably have templates set up as well. So I'm looking at this guy, and what plane do I draw it on? Right, this is where I first started with the first line of questioning. Do I draw it on the top plane? Do I draw it on the right plane? On the front plane? It's all up to you. It's about that design intent. How does it look now when I'm drawing the part to when I drop it in my model and I do an insert part? Is it going to land in pretty close to the direction I wanted it to lay? All right, so think about that. Or another thing to think about is when it comes into my drawing, am I going to have to do some kind of crazy magic and flipping this thing around to get my flat pattern just so, and then see my side views after it's been folded to be able to get the depiction right? Right, again, that's all up to you. For this instance, I'm going to show you a couple of different ways of doing something. So we'll start with the closed flange and what we were talking about there. I'm gonna come sheet metal, and now watch. I'm gonna try and go a little slow for you with some of my stuff because I use those, you know, crazy anomaly 12-point mouse gestures. I know you did, and I didn't. I don't think I exported my stuff. We'll be fixing that. We'll get another 4 hours of sleep tonight. All right, so I'm gonna go ahead, and you notice I went with my mouse gesture to the right. That was my contour flange or whatever. And I'm gonna come back to the right again. I'm gonna say I want to do a rectangle, and notice that it's got a center point and a corner point. So that's gonna allow me to pick the center of that rectangle where I want it. And I want to be able to pick the far corner. Now there's a couple of different things I can do here, just thinking about tips and tricks, but we want to lock it down. Everything we do with our design intent, we want to make sure that we have it fully defined. We talked about this offline earlier. If you haven't heard Too Tall Toby's fully define every time YouTube video, search it out. It's a jingle you won't get out of your head, but it's a great one because it reminds us to fully define. And if it's not fully defined, how do we make it to fully defined and find errors in that? And I've got another advanced tips and tricks later this week that talks about some of that too. So I'm gonna go ahead and click the origin since I did say center of rectangle. So that go ahead and locks that down for me. Now I can do a couple of different things since I have on-screen display input. I can go ahead and say I want that 2 inches high by, I don't know, let's leave what it is, 6 inches long, right? I could come back. Let's make that a little bit wider. Let's go 4, right? Now, notice as soon as I did that, it was fully defined. I didn't have to come back, didn't have to add dimensions. That's just some of those tips and tricks that we talked about in early meetings today that we've got recorded, and we'll post that out for you guys to come back and look at too. Okay, so we've got that fully defined. Now I'm going to bring my breadcrumbs down to me. Instead of coming all the way up to the top right, I'm going to hit R, in my case, D in your case, because I'm the anomaly with the different. I love that. I love how you said that. So I hit R and I bring it to me, and I can hit check that I'm done with that. Now, here's where we talk about the gauge tables or manual, right? And this is where you would normally hit manual. And if I wanted to do, say, a 12 gauge thickness, I could go in here, I could put 0.105 and hit enter. The K factor is already there that I would need, and it would automatically populate that at that thickness, right? And that's fine, that works. But if you have gauge tables set up, you can select the gauge table, go in here and pick, was it aluminum? Is it pipe? Is it rod? I'm just gonna say it's steel, right? It's just regular cold rolled steel. We'll go ahead and select that, and then I'm gonna come down and I'm gonna say 12 gauge. Notice it's already inputting that information for me. It's all defaulted. It's grayed out, so I can't change it. I can override it if I want to, but once you do gauge tables, no overriding, right? Let everything do it itself. That's the magic of it. We can reverse the direction, right? So it looks like it's going down here, but we can flip it and make it come up if we want to, right? We can change bend allowances or update the bend allowances and stuff. There's also some auto relief stuff we'll talk about here in just a minute as well. But I'm gonna go ahead and check that off. Now we have that closed flange. When we talked about the other one, let me create another part and we'll do it with the closed flange. I'll come back to front plane just for the heck of it for now. And up here's that base flange tab that I was talking about, and then just, you know, right mouse gesturing over to it. Coming back, I'm gonna select a line this time. Now notice I'm not having to come up here every time. We're using those mouse gestures Tank talked about, right? We're staying in home base. We're not running up our mouse miles. So I'm going to go ahead. I'm just going to draw that channel I had over there. Right. Then I'm going to come in and add a dimension to the bottom. We'll call that 6 inches. We'll call this one 1.5. Right. Instead of dimensioning the other side, I could have, you know, used a dynamic mirroring, or I can just grab both of these and tell them to equal. Now that's not fully defined, right? Now I could easily grab this point and drag it up here and fully define it. But in my case, that may not be what I want to do. If all else fails and you don't have a good design intent and you don't have a reason for locking something to the origin on a corner or extruding out in one direction, my opinion is, and this is my opinion, is that if you don't have any other reason to do that, always center your sketches about the planes. Right? So what I'm going to do is I'm going to come in here and I'm going to grab the midpoint here to the origin. I'm going to go ahead and set that vertically, and I'm going to do the same to this one, except for I'm going to set it horizontally. And now that's middle. It's kind of aligned with the planes and that orientation, right? Go ahead and use my breadcrumbs, the D key, bring that down here to me, check it off. And now here we have the option to go ahead and do manual again, or the gauge tables. We're going to run 12 gauge on this one as well. We'll go a little thinner. We'll run 14 gauge. So we're running steel. We're going to come in here. We're going to say 14 gauge. Now notice we can reverse the direction on here. Something to pay attention if you haven't messed with sheet metal is if the sheet metal is going in and I have it 1.5 inches and 6 inches, we're good. What happens when I reverse it the other direction? Yeah, so the dimensions on the inside. So that means the length of those legs coming up is now 1.5 inches plus 0.071 thou, 71 thou, right? So we're that much more. And then in the width of it, instead of being 6 inches, we're now 6 inches plus twice 71 thou, right? So you got to pay attention to that reverse. I always like to keep my stuff inside, just so whatever I dimension it, I know that's what it's going to be, okay? Could have brought those breadcrumbs to me. Actually, let me go in here and do one more step I missed. So as I was coming through there, I could go to direction 1, and we can go blind and we can take it out, I don't know, say 10 inches, right? But look how it came in one direction, right? We could reverse that direction if we want to. But do we want to? What did we just mention? If when all else fails, when in doubt, and you don't have a reason to set it one direction or the other, do it about its center. So now if we show these planes, they're going to be exactly centered with that sketch. All right. That's just going to help you out with a lot of things when you're doing width mates or you're trying to locate centers on centers, and just a lot of useful functionality there when you do that. Okay. So we've got this. Now, what is the difference? We talked about the different pieces of features we've done. Now here we've done one feature. If we went back to the other one and created those same flanges, we're going to have 2 features. But there's also some different things within the flanges themselves. So when we come in and we add a flange, it's one of the first tools we have up here is add a flange. We can come back and add a flange here, but watch what happens. We have a few different options to choose from here. Now, if we want it to run the same as that, we can tell it to run up to the vertex, and it'll stay the same length. No matter what you change those as, it's always going to go the same length, right? Now within that, we have a few other options. We have blind. We can tell it we want it to be a different length and height, or up to edge, and merge, right? But we also have to think about our condition. Look how far that is. Look how it's sitting inside of that material, right? So if I leave it alone now, it's inside of that depth. We set that at 10 inches. So that flange is within that 10 inches, right? But we see how we've torn the metal. Now, can a press brake tear the metal and make that work? Probably. It's going to have probably a little bit more deflection. It's not going to look exactly like this. And there's some ways I'll talk about here in just a minute about gap distance and treatments of your edges here. But before we get to that point, we can look at the other conditions we have, which that's inside the face, right? This brings you out just enough to where the inside face comes out. So from the inside face to the end would now be the 10 inches. This brings that and the radius out, right? And we can also even offset the flange and name it how far we want it to go out to, right? So if we just come back and we take the offset off, we run it here, we don't have any issues at all with that edge there. There's no tearing of it, right? And we can build onto that. We can add some more features, but a lot of times people like to close these corners up, right? So if we go back to the other file we were looking at where we have this guy, maybe we need 3 flanges. Maybe we need 4 flanges. Well, in a contoured flange instance, when you're looking at it and you're just drawing a few legs, you can only do those in that view, right? From that perspective. From here, we can add as many as we want. So I can come in here and I can pick each one of these edges and then come up top in my mouse gesture, and I basically just did the same thing, edge flange, right? I can tell it I want it to be 1.5 inches, right? I can tell it that I want it inside that. So whatever I made the parameters of the width and length of that plate, I can keep it within that, and look what it does for me. It doesn't tear it inside of the other radius, right? It still can do a tear, and we can adjust this gap distance based on our tooling too, right? We can adjust that gap distance, but we have it all kind of equally torn. The press brake is going to be much happier bending something like this versus the other one that we showed where it was torn all the way inside the radius. Back when we're actually looking at some of these flanges here, let's go back to this flange. We also have the opportunity to be able to change the direction. There's a couple of different ways. A lot of you guys probably seen this. It's no different than if you're extruding anything else. You can also come in and change it with the arrow. A lot of this is kind of similar to just your basic extrude stuff. When we get into the closed gap that I was mentioning again on this guy, talk about this gap distance here. It's set to about a 32nd. It is a 32nd, right? And we can tighten that up, and we can go to a 64th if we want to. Now look how close those guys are. All right. We could change it to a 16th. And a lot of times what that is determined by is your spring back in your sheet metal, right? Because once you bend a piece of metal, you have to over bend it, right? Take it past its yield point, and then it's going to spring back and be at its location. So that's when a lot of sheet metal or press brake operators, and they get your information, they have to put those calculations into the press brake, and they'll go and make that first bend, and then they'll put it on the gauge and they'll plus or minus whatever they need to add to that angle, because they're not going to bend it at a 90. They might bend it at a 95. Right? They may overbend it a little bit or underbend it a little bit, depending on the spring and the steel. Okay. Trim your side bends. Yep, you can do that as well. That also trims those back. That's he's going back to talking about in this other one. So if we come back in here and we edit this and we stay inside, we can trim side bends. Right? And that trims those back. Doesn't trim the flange back, but it trims the bends back. Now, I hate to knock on SolidWorks, but I used to use a 3D modeling software years ago. We're talking like 15 years ago. It was a Siemens product called Solid Edge. And when you did trim side bends, it would actually trim all of it for you. But there's still even a way to master that too, right? So we can come back and undo that. Bring this back inside, and we're going to talk about some control treatments we can have with it, right? So if we come up to the top, we have corners that we can work with, and we can close those corners, right? Because right now these are kind of open, and basically just bring them together. And there's different ways you can bring them together. You can see these different images here, and they basically do as depicted, where this will bring the corners of the flanges together and meet them up, or you can overlap one over the other. And once you do so, you can select it. It automatically kind of picks the other one and fixes that for you. But again, that's another feature in your tree, right? We want to play it smart. We want to have the design intent of what we need to happen at the end game, right? We want to get that checkmate with as few features as possible, right? So there's a lot of different ways we can skin a cat and using some of those different features. Let's see. So yeah, we're selecting multiple ones. We got the gap distance, corners. We can also change angles. So if we come back here for the fun of it, we can actually change our angles. And we can say instead of 90 degrees, we want 100 degrees. Notice how that tapers in for you, right? If we did the opposite, right, and we said 80 degrees, it goes out, but it doesn't extend them, right? as it did when it tapered it in. Now you can do miter flanges and stuff, and I think I get a little bit of miter flanges today, jogging them out and stuff, and I'll talk a little bit about those, but they can kind of come together a little bit for you and wrap around. So that's the changing of the angle. You can, if I remember right, I remember if you can change them individually or not. I'm wanting to say you can't, because it doesn't let you select it and change them. It's all together. There is some options where you can come in later and modify sketches and do some modifications and change flanges individually that way. Flange length, and that's actually the next thing we're going to talk about. So whether that's in this, or you're adding a flange somewhere else, you can easily expand these flanges and come in and see how they give you the different sketches that are created. I'm going to probably talk about this in my next sheet metal presentation, but I'll talk about it a little bit here. Sure, but sign of hands, how many people know what a minus sign next to a sketch means? It's undefined, right? Okay. So is that sketch undefined? Or is it defined? Well, let me ask it this way. Are those, so I'm gonna rephrase the question. Is that feature defined or underdefined? Yes. Almost anything you say here could be a yes. I've asked SolidWorks so many times about this because it's just, it boggled my mind, and I finally just took it for what it is. And I finally actually think I understand it, because if I go in here and I look at the sketch, you're right, it is underdefined. But is it really underdefined? No, because it's defined by the feature. Right? So, and what I say about that is because if I come in here and I edit the feature and I change that from 1 inch now to 2 inches, that was 200 inches, 2 inches, notice how it controlled the sketch. It controlled the flange. So the feature is actually defining the sketch, even though the sketch isn't defined. So the feature could never deviate from what the sketch could never deviate from what the feature says, unless you define the sketch. Once you define the sketch, the feature dimension is now null and void. Does that make sense? Took me a few times questioning into that before I finally wrapped my head around it myself. So completely understand. All right. And so I'll explain that here just a little bit more. So now we're at 2 inches. The feature itself here, where we edit the feature, that is fully defined and it's defining the sketch, but I can come in here and I can manipulate this sketch independently. Notice we do have a blue line. A blue line means what? Underdefined. What does it tell us down here in this bottom right-hand corner? Underdefined, right? Those are where we double check ourselves, make sure things are fully defined. What's a good way of finding out where it's underdefined? Grabbing a point or a blue line, moving it around, right? That's how we know it's underdefined there too. So now we can come in here and we can add a dimension to this point and make it 1.5. And now we bring our breadcrumbs to us and exit out, so we didn't have to go to the corner and waste time there. And we've actually fully defined this sketch now. You notice something missing? The flange length. We have now made that feature driven definition null and void. So if you don't define the sketch, it's going to be governed by the feature. Unless they're really OCD, like a few of us. Now, I did go back and define the sketch for a long time. I did, until I questioned SolidWorks enough to where I felt comfortable that it was really being defined by the feature. Now that I feel comfortable with that, I understand it's being defined by the feature until I edit the sketch. Right. Now I can undo that. Let's go ahead and undo that real quick so we can bring back our what we were at the previous time. That's where I just drug it around and changed it. We have a new redo key. Everybody knows about that, right? course, it's not gonna let me redo. It's supposed to be a better redo key, but it's not available now. So I'll just go ahead and create those flanges again. Click them first, otherwise you have to go back and click that window every time to add the edge. Grab your edges first. And create that at 2 inches again. All right, and so as we expand these, another way we can edit these flanges, and if you're doing a single flange, it's a little bit easier, but another way we can edit these flanges is we can come in and edit the sketch. What if we didn't need one leg on that box to be the full length? You can set them different. I can grab that leg and move it off. That's another weird thing about flange sketches too. That's technically fully defined, right? That's even a black dot right there saying it's connected to that edge, right? So that's another one of those misnomer tricky things about flanges and sketches, because it should be fully defined, but is it? If it was, should I be able to move that? No, but they understand that that may be something you want to do, so they make it a little easier for us to be able to do that. And you know what I could do is then come in and maybe say I want this midpoint to be, grab the origin here. It doesn't want to grab there, so I'll grab it here and say I want it to be vertical with the origin, right? Again, I'm thinking design intent, right? Because now if I put a dimension on that and its length, I could say 5 inches, but what's that 5 inches always going to be? Centered. So there's some design intent for you. I could have went back and said, oh, well, that's 6 inches. Well, let me add a ½ inch on each side. But then when I change the length of it, you know, it might be centered for that matter. But what if I need to change the length of the flange in the middle too? You know what I mean? So it helps us keep it centered. That's more design intent. And then we can come back and add the length. But what does that do for us? We come back, we see we got one leg edited. We come back to our feature, and we still have the flange length available because we didn't change the height. This is only controlling the height, right? We talked about the different edge conditions and the gaps here. This is all dependent on your tooling, right? Are you punching this metal? Are you lasering this metal? If so, if you use a laser or plasma, how thick is the beam, right? Do you have to make it an 1/8 inch, or is the smallest die you can punch with a 1/4 inch? So that's how you can always determine this. Basically, when you come in and you utilize that and you come in your edge, it's going to be in your features of it. You can set a template one right at the beginning if you want to, but you can always select a custom bend relief when you roll down. And I can say I want it just to tear it, right? In this instance, it would probably tear it, but it's probably going to roll the sides a little bit, right? Because even though it shows it one way, we got to think, what's it really going to do on the press brake? So yeah, it could roll the sides, but it's probably going to tear a little bit too. So tear is probably not your best answer all the time. Again, it's all depending on tools. Let's go rectangle. Maybe we just have a laser or plasma that's cutting that thing out. I don't want to use a ratio because maybe I know that the width of my laser is an 1/8 inch. So I set that gap width of an 1/8 inch. But it really doesn't have to go in that far, right? It really just needs to clear the bend. So I can bring that right up to the bend and go 0. Not only did it change it on that side, but it also changed it on this side. And it will for every other one that I modify and change as well within that feature, unless you preset it. All right. Along with that, and I'll go back and show you another real quick way of doing it too. And you can again pick any one of these sketches that you want to edit. You could go in and even modify this one step further. That when it first created, it also gave some relationships to it, that these lines were vertical, this line was horizontal. But what if I really didn't want that line to be vertical? I wanted to add a dimension to it and say that that really needed to be chamfered at a 45. But now look, the dimension's up here, so maybe I didn't need that dimension up here. Maybe I needed it down here. Just moving it all around in it. But that's because I have it set to this midpoint. So let's change our midpoint. Up here, grab that guy, select midpoint. See if it'll let me select the origin this time. Oh. I broke it. It's not wanting me to select that origin. Doesn't like it. There we go. All right. And of course, this is going to change the height, so it's going to throw off our feature dimension as well. So you got to keep that in mind. But there's plenty of ways you can go in and edit these sketches. You don't have to just live with what it gives you, right? In saying that, what if we didn't have any of these guys? What if we just needed one flange to come up from right here? We're going to add that edge flange again. What if we know in seeing into that design intent and that future versus having to go ahead and make the flange length and height and all that stuff? What if we know that we can actually come in and edit the flange as we're creating it, move our walls in, and for the sake of time, I'm not going to go into mention anything, move our walls in, we can change our angles, whatever we want to do. Once we finish that, we can say finish and it'll go ahead and do it for you. So we can do it as we're creating it. We don't have to go back to it. Although going back to it's nice too, because hindsight's 2020, right? Design intent's great, but hindsight's 2020. All right, so looking at the miter flange. Miter flange is unique in its own. So if we pick this edge and we come up and we select miter flange, which is going to be our next tool, our next feature in the bag. We select this edge, come in and grab a line, connect it here. Maybe we know a certain shape that we want to create. Right? I'll kind of go ahead and dimension some of this out. Make these points vertical because we know we want that whole edge to be the same. Let's throw that up there, 45. All right. And we know we want this overall height. Be set at 2 inches. Maybe this leg at 3/4. And set our gap. At a 1/2 inch. Okay, so now that we've got that fully defined, we come back. We can select our edges. That just shut off. I think that just let the camera shut off. Now we select our edges, look there. Another thing we got to think about with design intent too is it manufacturable, right? You may be able to get this on a press, but you're going to be able to get dies all the way in here and create these bends. You might be able to. It just depends on what kind of dog legs you may have on your dies on your press brake. But you notice I only had to draw one of those flanges the way I wanted it. I didn't have to go in and add the contours like we talked about. So this, if I wanted to do it, say with the base square without using a miter flange, I'd have to create at least 1, 2, 3, 4 flanges on 2 different edges, maybe mirror it out, do whatever, right? Another thing I could do is do the contour flange, create it one way and the side view of it as an open contour sketch, right? And then come back and try and create it on the other side. And then hopefully, close the corners. All right, but with the miter flange, it's going to actually just let you sweep that all the way around pretty much and connect it and miter it and give you that full seamless look. And again, you can go and set your gap distances and all that stuff too. they're okay. I'm not a fan of sketch bends. I'll show it to you just because I have it on my list to do. But I'm not a fan of them. They do serve a purpose, I guess. But if I came in here and say this top plane, and I drew a rectangle from the center, for sake of time, I'm not going to mention anything. We'll go ahead and just set it whatever. Doesn't really matter. So when you do a sketch bend, you're actually going to pick the sketch. Say I want to put a line so far off this. The reason I'm not a huge fan of this is because you got to kind of pre-calculate your bends and where you want that center bend line to be able to form a certain angle. I'm gonna go ahead and create that. Now that I have it, I can come in here and create a sketch bend. Create the, grab the line. Let's see if it's gonna work for me here. Let's try this. There we go. So I went ahead and create, just to speed the process up instead of picking it afterwards. I went ahead and picked the sketch line that I wanted to bend at. That's going to be the center bend line for you. Then I went and picked sketch bend. I told it what surface I wanted to lay down and then pick the other surface up. So almost like I'm sticking it in the press brake, right? I want the surface to stay down, the press brake's bending the back surface up for me. Basically, if I'm holding it in my hands, the way you could think of it. It does serve a purpose. I mean, I guess if you're in a top-down assembly and you got a piece of sheet metal you're sticking in there and you're trying to line something up, I guess you could work it that way. But I use a lot of other tools that are a lot quicker than that. Hem bend. How do we put a hem bend on anything? What are hem bends good for? Hem bends are great for protecting your customer's hand, right? So they don't get cut by sharp edges. They're real easy. There's nothing to them. You just select the edge you want it to go to. Select your hem bend tool in that feature tool bag there. You have different ones. So you can do your material inside, outside, of course, just like before, but you could say you want it to be closed, you want it to have a loop, you can have these teardrop shapes, or you can add as if it's being put in a roll former, right? So you put it in, it kind of rolls it on top of itself. I think the most standard typical one is probably this one that folds down on itself, because a lot of times what the press brake will do is they'll stick it in, create the bend and bend it over far enough, and then they'll pinch it together. All right. That's probably your most standard and easiest one to create. And then say we only want to create it at 3/8 long, right? You're not really worrying about the relief type here. Maybe if you had it in between a couple of flanges, you would worry about the relief and maybe the gap distance of your tooling like we talked about earlier. But then there you go. You got an edge that's protecting somebody's hand. Great tool for hem bend, or even something else for that. Maybe you're running wire over that edge, right? Anything you want to be protected, you want it, because as soon as you shear, you punch, or you cut something on a sheet of metal, and especially I would say the thinner it gets, the worse it gets. You create this burr or this sharp edge that's so time consuming for your manufacturing team to remove, right? And of course, time is money, so we want to speed up that process. And if putting a hem bend on something's going to do that, let's do it. All right. Come back here. All right. So some of the key takeaways from here is notes that you may have jotted down or put in your head is how to choose your planes, why we would choose certain planes over other planes, creating a gauge table. Hopefully that piqued some interest and you guys were thinking about gauge tables. Maybe you tune into the next sheet metal one when we talk a little bit more about that. Creating flanges and the way that they need to be created, whether it's open contour or closed contour sketch, and the way they format with edge flanges, creating more of them or hem bends or whatnot. Create and use design intent, right? And then creating templates that work with you, right? So make sure you have some of that stuff pre-set up, so that way you're not having to reinvent the wheel every time you open a part or even a drawing for that matter. Call to action. I really like to challenge everybody in everything I do with all my presentations. It's just to give it a try. If it's one thing, take it with you, utilize it, try try it out, by all means, throw it back away in the trash, don't use it anymore. But if you can take at least one thing out of every meeting, every presentation, every SWUG group you go to, take it back with you, you will become a more efficient and better SolidWorks user and a better employee for your employer, whether it's current employer or future employer. So keep that in mind. Start with the basics. We hear this in sports all the time. People make these errors and fouls and flags and penalties because they don't remember the basics. So start with the basics. And if that means, making sure everything's fully defined, that your feature tree's in order, the design intent, all those things, right? And that leads into the next one is create it with intent. Create it like you have a purpose to do something. Don't just wing it. Learning exhausts the mind, of course, right? Or never exhaust the mind. And seeing then doing, you learn by, right? So once you see it, do it, put it into action, and turn it into stone, right? Is there any questions in regards to anything about sheet metal that I can answer for you at this time?
On the sheet metal, after you bend everything, I guess that's a whole nother class on if you're gonna make a drawing, because you want it flat, but they go with the plasma, whatever, and then they go to bending it.
Correct. And we get into a little bit more in that next sheet metal, advanced sheet metal later this week. We get a little bit more into the flat patterns and how to manipulate those flat patterns. Because a lot of times your flat pattern may look different on a drawing than it does in your model, and why? Where is it being held down by? What is holding your parameters and telling you that it's the surface to be pinned? All right. So yeah. 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 And that's the really cool thing about some of these new air bending machines or press brakes or like laser cutters and stuff. You can set up SolidWorks models in such ways that up bends create a purple bend, center bend line. Down bends create a blue center bend line. And so with those tools, you could about CNC the whole thing just off of the Parasolid. I mean, it's almost like a CNC machine, right? You stick it in, the flat pattern goes in, they nest it with Sigma Nest or whatever tool they use. They cut it out after it's nested with a group of other parts, and then they take it, throw it in an air bender, and it bends itself. Depending on your manufacturer. If you manufacture in-house, I know if you manufacture and you send it out, you may have to dimension every hole pre-bend and post-bend, right? Because they may have a QA department that's going to go through and measure those out and make sure the holes are in the right place and the bends are within tolerance and all that good jazz, right? But then again, if you're in-house and you're throwing the drawing to your shop floor, why do you need to dimension every hole, especially if it's custom one-time build? They're never going to check it again. It gets put in the Sigma Nest. You trust your programs to do their job. You just give them a post-bend dimension of the overall. Great question. Yeah, but we will be talking a little bit more about flat patterns and stuff. Let me look. You got my phone over there or the Eventbrite page? Yep. Yeah, we have. So this is just 4 out of our 12 presentations. We've got 8 more presentations this week. And I promise you, I know that if you've watched the one from earlier today, there was a little bit of overlap between mine and Brad's stuff. And with my peripherals, there might be a little bit of overlap with that, with a little bit of Brad's stuff. I promise we didn't get together. We didn't look at each other's presentations. It's just the way users do things. Some people do things alike and some things are different. And even the overlap we had, it was still different. The overlap was still different from my tips and tricks and some of the stuff he said today. Friday's advanced sheet metal. It'll be Eastern time zone too, so keep that in mind. It'll start 6 p.m. Eastern time zone.
I met some points I made right or wrong where in a marked file and then a piece of sheet metal and then 2 get welded with other things. Now flat pattern I've got to play around and trick SolidWorks to say, show me the flat pattern, because over there, the templates, when you break down the drawing, the flat pattern goes away under certain figs. If I go and make a fig without those welded on pieces, show the flat pattern, then elsewhere in the drawing, show the welded.
There's, I'm glad you brought up configurations, because my bro man over here later this week has a presentation on configurations, the good, the bad, the ugly.
Based on what you're talking about, are you trying to keep it in one single part file?
Yeah, I was, rightly or wrongly, yes.
So, yeah, are you cutting apart the whole tab or whatever separately, welding it on?
Yeah, right, exactly. So I would show, whatever, some box, whatever. And then say, okay, well, lifting to it, lifting eye or something to it. And, since you're not merging it with the sheet metal.
Because you're trying to do it, it sounds like you're trying to do it almost like a multi-body item within one part. Yeah.
It is multi-body. But flat pattern goes away as an option for you. So I have to trick it.
Yeah, the auto out body.
Okay, I just know if
Yeah.
if there was a better, cleaner way. to do it.
And
Without making it simple.
It's definitely the best way to do it at that point, as far as
Yeah.
keeping your flat pattern separate from the one. I think that's what we agree.
Yeah, I agree.
Anytime you have a building operation,
Make it a
you
set.
might come apart with a single part later.
The reason, yeah, so are you saying, and I can see it a couple different ways, maybe what you're saying, but yeah, keeping it two different parts, if you're gonna create a sub-assembly later, do that. And I know sometimes for the sake of losing parts throughout your process and your manufacturing process, you may have those parts kind of nested together, and maybe it's just a little 1/8" flange for you to be able to break it off and use it later because you don't want it to get lost. Then maybe a little part you don't want to get lost in the mix of all the other parts. And so I can understand where you're doing that, and yeah, making that a configuration and showing that that is one part, and then going over and being bent off, and then showing, like Brad said, yeah, putting it in an assembly would probably be the best option.
That way, right now, you're actually creating extra parts. That's what you're trying to do, right? You're trying to avoid creating extra parts.
Yeah, right. It's just.
Yeah.
More practice, more-
Good thing about the PDM system is part numbers go to infinity. Part numbers go to infinity. I know we don't want to duplicate parts, of course. I'm not in encouraging that by any means, but yeah. But I can definitely understand where you'd want to keep it at least two smaller parts together to keep from being lost in manufacturing too,
Well,
if that's the case.
plus, the way we design something, a weldment is usually a part. Part.
Yeah.
So,
You use the weldment feature that's all to design parts and then cuts it out as spots.
Well, most of the parts are welded, not all parts are welded, but when we do assemblies, they're all parts. We don't have welding within the assembly.
Yeah.
typically an assembly for us. Items that are bolted together, pressed on, something.
Yeah.
Hard, it's standalone, something welded or something else, make sheet that.
Yeah, you guys probably, I could be guessing as far as your parts and stuff go, when you weld them together, are you running like cut lists of just, okay, this rod or this pipe for this length, and you don't have a standard part number, you're probably just calling out certain gauge or scheduled pipe and length kind of thing.
That mode over time.
Yeah, and that makes sense.
Sometimes we would have outside fabricator, when you're in the sheet, we have it in-house. Now,
Yep.
everything's outside in.
Yeah, that makes sense. Yeah, and if you need some more insight or input on that, feel free to, if you're able to, right? Feel free to send that to Brad or myself. We'll look at it. We can send it to people we know at SolidWorks for some more insight at that, on that nature too. So.
There's a way maybe we can play around with it.
And I don't want to take away from TriMec and their support teams, because they have a good support team. And, you know, if you just, TriMec@support.com, send them the file and say, hey, do you have suggestions? Maybe they could help you out too. Yep. Any other questions?